Okay, question 5 is about probability. So we're given 28 different socks, 16 black, 10 white, and 2 green. So we kind of like just took these out of the laundry maybe, and so they're all shuffled about, they're not paired up. So we're going to answer some questions about probability. So part A is, what's the probability that both of the socks are black? And one other note is that it says that we're taking 2 draws without replacement. So we don't put the sock back and then grab another one, we just take 2 out. Okay, so part A is, what's the probability they're both black? So first, the probability that the first one is black is 16 divided by 28, because there's 16 black socks and 28 total. And now for both of them to be black, we need to multiply this by the probability that the next sock is black. So now how many black socks are there? There is now 15, because we already took one out, divided by the total number of socks, which is 27. So we don't need to simplify anything, so that's our answer. Part B is, what's the probability that at least one sock is lime green? So at least one sock means there could be 1 or 2 lime green socks. So we could figure out the probability of one lime green sock and then add it with the probability that both are lime green, but that's pretty hard. So instead we're going to use what's called the complement rule, which is that the probability of an event, let's just call it A, is equal to 1 minus the probability of not A. Because something either happens or it doesn't, so we can use this formula to our advantage. So in my opinion, it's a lot easier to find the probability that none of the socks are lime green, and then just subtract that value from 1. So the probability that the first sock is not lime green is 26 divided by 28, because there's 2 lime green socks, and there's 26 non-lime green. So in order for this to work, the first one has to be non-lime green. So now there are 25 non-lime green socks left, and 27 total. So 25 divided by 27. So that's the probability that neither are lime green. But now we still need to multiply, or not multiply, we still need to subtract this from 1, and that's our final answer. Okay, part C is the probability that 1 is black and 1 is white. So there's 2 ways this can happen. It can either be white and then black, or black and then white. So let's first do black and then white. So the chance of black first is 16 over 28 times the probability of a white sock on the second one, and that's going to be 10, because there's 10 white socks left, over 27 total socks. Now we're going to add this to the probability of white and then black. So there's 10 white socks over 28 total, multiplied by 16 black socks over 27 total. So there's our answer there. Now part D, the probability the 2 socks are not the same color. Okay, so to get not the same color, there's actually a lot of possibilities. You can have like white then black, black then white, white then green, etc. And in fact, there's 6 possible choices. And that means we have to add 6 different probabilities, which is not fun. So again, we're going to take advantage of the complement rule. So we're going to do 1 minus the probability they are the same color. So let's first calculate probability same color equals. So there's 3 ways to do this. There's black and then black, white then white, and green then green. So first we can do black then black. So 16 times, or over 28, times 15 over 27. We actually got this in part A. So we're going to add this to white then white. So that's going to be 10 over 28 times, there's now 9 white socks left. So 9 over 27. Now we're going to do the greens. So there's 2 green socks 2 over 28 times, once you take one green, there's only one left, so 1 over 27. So, the probability of not the same color is just going to be 1 minus p of same color, which is all this stuff.